right? And this side is the opposite. And so I would say, let's see, the sine of 30 equals, I don't know what this side is, so I'll call it x, I guess. Opposite over hypotenuse, x over 1. Do you see how I don't even need to cross multiply? X is just going to be the sine of whatever 30 is, because it's over 1. Okay? All right, so what we're going to do right now is we are going to talk a little bit about those special right triangle rules so that we can actually figure out what that would be, because if you put it in your calculator, you're going to get something like this. Well, 0.5 is not too bad, but if we put in like the cosine of 30 degrees, which we'll do in just a second, you get something like that. Nice and nasty, so let's just try to remember the rules. Does anybody remember the rules for a 60-90 degree triangle? 60, 30, 90? I thought maybe Garrett would. No, Garrett? Okay. So the rules for a 30, 60, 90 degree triangle are as follows. Over here on the short side, you have x. Over here on the hypotenuse side, you've got 2x. And over here, this side, is x times the square root of 2. Or is it x times the square root of 3? I think it's x times the square root of 3. Let me make sure. X times the square root of 3. Yeah, x times the square root of 3. Okay. So if this side equals 1, so if 2x is 1, you guys, then what is x? Anybody figure that out in their head?
0.5.
Good. So over here, x is, I'm going to call that 1/2. Still 0.5, same thing, right? And down here, it would be 1/2 times the square root of 3, which is the square root of 3 over 2. All right, now this is a hard thing to understand, and so I'm going to say it extremely slowly. And I know that it's a Friday, and I know that it's super early in the morning, and I know that this week has felt ridiculously long because distance learning sucks. Can we all agree? It's not fun. I don't like sitting here at the computer. I don't like sitting here without you guys in the classroom. I miss you. I miss you like a whole bunch, actually. Don't tell anybody. This is really embarrassing for me, okay? But I do miss you. But right now, I need you to focus because honestly, paying attention in the next 5 minutes out of the whole class is going to save you a lot of time in the next 2 weeks. Okay? Everybody with me? Okay, because I'm going away from your faces. Okay, here we go. So you should have on your triangle that this side is 1, this side is 1/2, and this side is the square root of 3 over 2. And the reason is because these were the rules for a 30, 60, 90 degree triangle. And this isn't something you're going to have to prove over and over again. This is something that we can prove once, and then we're going to write it on our circle. Okay, this is hard to understand, so focus. The sine of 30, we did that by saying that the sine of 30 is this opposite side, that's x, over 1, right? And x turned out to be 1/2, so the sine of 30 is 1/2. Do you see how the sine is this distance? And that only works in a unit circle. So this distance right here, this y distance, is 1/2, and this x distance here going across is the square root of 3 over 2. So if I was to write it, I'm going to write it on this unit circle. Don't you write it, okay? I want your unit circle to be pristine. I'm going to wipe mine out in just a second. But to help you understand, this distance right here is 1/2. And then this distance under here is the square root of 3 over 2, right here. All right, so for the first prize. What is that point? We know that this first point was 1, 0. And I just told you this distance. And I just told you this distance. So what's this point right here? Raise your hand digitally if you think you know the answer. Okay. So I'm saying David, Cruz, Mitchell, T, and Crystal. One. David. Tell me, David.
It's going to be the square root of 3 over 2 and 1/2.
Good, because this distance going across, this x distance going across, like this is a point, right? And that first letter in a point is x. This distance is the square root of 3 over 2. So right now on your unit circle, you're going to write this point down. Don't write what I wrote on the triangles here, but do write this. The square root of 3 over 2 and 1/2. So that's what we've got so far. All right, now you're going to take your straight edge and you're going to draw in another triangle. And that looks like that. Do you see the triangle? Here's the right angle. And I'm going to draw that picture on my sheet again, on my scrap piece of paper. Okay, now what do I know about this? Anybody have any ideas of what I know about this triangle? Come on, we definitely know something. You can do it.
It's an isosceles triangle.
It's an isosceles triangle, that's true. And if the base angles are the same, then that means these are going to be the same, right? Do you remember that from geometry? So this is the same and this is the same. I'm sorry to tell you this, and I know that it's freaky, but it turns out that when you start getting into pre-calculus and calculus, you actually end up using the math from all of the classes that you've taken before that together. Blah, right? Yeah, it's going to happen. Okay, so here's x and x. We also know how long this hypotenuse is. Anybody remember? 1. Good job. Okay, all right. Anybody remember the rule for a 45-45 triangle? Well, luckily, we can totally figure it out with the Pythagorean theorem because we don't have to do it with just that. We can do it with the Pythagorean theorem. So let's do it. So a squared plus b squared equals c squared, right? So it doesn't matter which side's a, doesn't matter which side's b. That's x squared plus x squared equals 1 squared. What's x squared plus x squared? 2x squared. You could just unmute yourself, but if you want to really like go for it, fine. It's 2, and then there's like an x, and there's a square. Square on the top, and then there's an x. It's an x and then a square. Okay. So if I try to get x squared by itself, I'm going to divide by 2 on both sides, and now I've got x squared equals 1/2. And then what do I do? How do I get rid of the square?
Square root.
Oh, look at that. You can talk. That's very nice. So you end up with x equals the square root of 1, which is just 1 over the square root of 2. But here's a thing that I haven't taught you yet. You know how there's a whole bunch of stupid rules in math about things you can't do? Anybody know a rule in math that you just can't do? There's a few things you just can't do. What's one thing you can't do in math? What?
Divide by 0.
Divide by 0, can't do that. Anything else? You can't have a negative under a square root unless you use imaginary numbers, right? Okay. Another rule is they don't like it when square roots are on the bottom of a fraction. And it's not because it's like illegal or impossible. In fact, if you put it in your calculator, it would work. It's just that it's not like, it doesn't make calculations easy. It's easier to have square roots on the top. And here's an easy way to always solve this, and this is called rationalizing the denominator. So I'm going to multiply by the square root of 2 over the square root of 2. The square root of 2 over the square root of 2, that right there, look up, that's 1. Do you understand what I'm saying? That's 1 right there, so I'm not really changing it at all. So if I multiply, I get 1 times the square root of 2 is the square root of 2, and the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So you see how that gets rid of that square root on the bottom? And that trick always works. So each side here is the square root of 2 over 2. And again, you're not going to have to do this over and over again. We're doing this once, and we're doing it together to get it right. So now I want you to imagine that this triangle